Hi, everyone. My guest today is Peter Sjoberg. He's Global Vice President for Solution Architecture for Cloudian. And in this conversation today, we'll get into the infrastructure layer, like this part that often gets ignored in the AI hype conversations. We'll talk about storage matters more than you think, and what AI-ready infrastructure really looks like, and how companies can unlock value from that, and much more. So let's go right into it. Peter, welcome to the podcast.
Thanks. It's great to be here, Ivo. Appreciate it.
Great. So let's start at the bottom, really. Cloudian is known for object storage. Why does storage matter so much in today's AI ecosystem? What are people, let's say, underestimating?
Well, I think everybody understands how storage, or let's say data, is central to any AI solution, any AI workflow. Well, that data's got to come from somewhere. Largely, organizations have been storing data for all kinds of purposes. What we're doing now is unlocking that value in that data more readily. Database data has always been part of this conversation, but unstructured data, or just sort of general data like text files and audio files, video files, all of the things organizations have captured and maintained for years now can be exploited for training models or operating influence with augmentation. So much of that data is stored and should have been stored with object storage. And now we're seeing how organizations that have been using it in one workflow, maybe as an archival workflow or a protection workflow, can take object storage and move it into an AI workflow. Same platform, enhanced capabilities we could talk about, but certainly people want to take advantage of that, and they may not necessarily have realized that as they have built out their IT infrastructure.
Right. So IT infrastructure, we mentioned the AI-ready infrastructure. Now, what does that actually mean? Is it about bandwidth, latency, cost? How does that play together with the cloud hyperscalers? And how do you view proper infrastructure?
Yeah, AI ready is really a term that says, listen, I have a bunch of AI infrastructure, or I have a bunch of infrastructure. Am I ready to try to exploit AI and use my data to better my business outcomes? Because that's really what it is. The reality is you have to start with a workflow or a problem you're trying to solve, and looking at how can AI augment or solve that problem. Most organizations sometimes struggle to define AI infrastructure when they haven't fully actually defined the problems that they're trying to solve. Now, the catch with AI is we don't know. We don't really know all the things we're going to be capable of doing. So can we take advantage of technology today that will be solving those AI problems of the future, even if we haven't fully identified them? And so to me, that has a couple of steps. Obviously, when we speak of what Cloudian can do and how we work with organizations, it's about capturing and storing the data. One key step is simply ingesting and storing raw data. Being able to do that at scale, whether it's sensor data or multimodal data, is certainly oriented to object storage, and having a platform on your premises that can do that, really powerful. But then that data needs to go through several different iterations, meaning it's got to be prepared, it needs to be vectorized, it probably needs to be aligned to GPUs for some training. So having the storage, having the capabilities, maybe is one element of being AI ready. Certainly it's not the only element. There are a lot of tools and tooling that need to be handled. And of course, even the compute technology, right? We're seeing almost what we call a gold rush towards GPU technology, so that organizations can get control of these high performance, very capable processors, so that you can exploit AI data and solving these AI problems. So perhaps the two most focused areas of AI becoming AI ready are building out a storage infrastructure and building out a compute infrastructure that can be leveraged for today's problems and continue to be leveraged and scaled for tomorrow's.
Right. And also most companies are just sitting on just a mountain of unstructured data anyway, right? Without it, maybe with partially realizing it or not fully realizing it.
Exactly.
But why? Can you elaborate a little bit more on what's the choke point? Why aren't they not using it in AI as quickly or as much as they'd like?
Well, because the biggest issue has been you've been storing data forever. This is not a new thing, right? Whether it's on premises, in the cloud, in a file system, in an object store, it doesn't matter. You keep storing data because you need to. It's been part of IT. Is that data ready to be exploited? What we're finding is that many organizations, they might have it in a file system, which is very common, a shared file system, let's say, but that file system doesn't necessarily have the performance characteristics. It might not even have the governance characteristics. We can dive more into that, but you don't know exactly what you have And therefore, you need to move the data. And we all talk about these terms, maybe overused, data has gravity. If it's in a platform that's not exactly usable, that's a big lift, a heavy workload before you can even begin to exploit the data. So I operate with the notion that every piece of data you store should be preserved in a way that can be exploited or taken advantage of for AI. The idea is you are going to use that data. Let's say it's podcast recordings. Let's say it's documentation from your company. Make sure it is in a format, in a location that can be accessed and guaranteed to understand what that data's value could bring. Today, it's locked away. Data silos have been an issue for a long time. Now we need to undo some of that. I think one of the major steps that was happening over the last several years is creating data lakes, where a lot of this data came in and it was stored for the use more in analytics properly than in AI. But that same data set now becomes an AI platform for data that can be moved into GPU clusters, moved into an inference, let's say like a RAG or even a CAG augmentation solution. So the idea here is we have to have that data stored. We have to have it ready in a format and a capability so that it can be read by the systems. Lots of databases, lots of file systems, lock away or isolate that data. Protection's a great example just to throw in. Many organizations protect all of their data, which is wonderful. But is that data in a format or in a location or accessible to being able to go into an AI system for evaluation, training, et cetera? In most cases, it's not. And that's a real challenge because you have to reload or reaccess that data.
Right. And one interesting thing is that we see is the hybrid cloud comeback, right? Rise of the hybrid cloud. And in Europe, there's a lot of talk about sovereignty, but also cost, latency. So this thing is real, and it's almost as if you want to have the advantages of the cloud, but without having the disadvantages of it. Having a choice between the storage and the compute, and kind of moving away from this hyperscaler only thinking is really in right now. How would you view this development?
Well, I think quite simply, if you just look back maybe over the last 10 or 15 years, before I get into this, I should say I've spent the last 5 years working at a hyperscaler. I've just recently, in the last 6 months, come to Cloudian. And in my life at a hyperscaler, I made that move because it felt like the whole world was going to cloud. And there's a lot of great reasons for that. I'm not at all against what the cloud can offer, but it does come with its challenges. So maybe a hybrid model will be a much more common model for the future. And the reason is, the hyperscalers, every one of them are going to offer you a capability to not just store your data, but they have an incredibly large tool set, including compute resources, to be able to leverage your data. That's a real benefit because you don't necessarily know what you need. A lot of organizations are going to struggle to go buy and even acquire GPU technology themselves. So there might be a good reason to have a certain data set up in the cloud, ready and accessible for something like AI model training, simply because they can use those GPUs that are expensive as they need to, but not necessarily buy them and have them on their own floor. Well, a lot of organizations are going to say, I'm not super comfortable with that. One of the most basic reasons why we've seen people repatriate out of the cloud, and this has been an ongoing conversation for a decade, is cost. Frankly, if you can manage your own infrastructure and do it efficiently, you can probably save maybe 70-75% off of cloud storage costs. I mean, size, scale, all the details aside, it can be tremendously beneficial. The reality of that is it's hard not to take advantage of that. So you might say, I can't afford to be in the cloud simply because I have ancillary costs. I have all of these things I can't really control. And to be honest, it's hard to control them. So
Right.
Folks say it costs too much. My feeling is you can control it perhaps better on premises.
Right. Well, I'll push back a little bit on 75%. Well, I'll tell you what, though, cost certainly is a thing. There are certain, really, the answer is, the consultant answer is it depends, right? For some cases,
Yes,
you'd probably be able to save more. For most things, probably be comparable. But the main lens that we view this in Europe is especially in the sovereignty, governance, compliance, and security aspect. How do you think the evolving landscape of hybrid contributes to improving all of those, let's say, non-cost aspects of
sure.
the advantages of hybrid?
The concern, of course, is very evident today in our climate, that people want to have not just control over the data, they want to be able to look at it and point to it. There's a huge push to move off of hyperscalers, simply because as much as you have your isolated and secure data, it isn't under your direct control. And that is an uncomfortable situation, depending on the business you're in, the hyperscaler, even the country that you live in.
Right.
Being able to
Absolutely.
guarantee sovereignty is an important step. And we're seeing a rise of cloud storage that is very localized within a certain country, where a company can say, I'm confident with the cloud capabilities, but I need to be able to see that data. I need to know that it's resident in my country and that it's governed by the laws of my country, or perhaps the EU, a larger body, that I don't feel are going to be handled the same way when they're outside of my control. The reality is, we've seen this. That data is your data. It is something you're responsible for. So if there are legal actions that include that data, that's your company's responsibility to manage. If that's outside of your control, how can you guarantee that that data is handled in a way you feel meets your legal requirements? There is some hesitancy. And that's one of the biggest reasons that sovereignty can be pointed to with a system like a Cloudian hyperstore, which is a system that is either hosted with an in-country cloud service provider or hosted directly on your own premises. Either one gives you that certainty the data is governed under the laws that you can control and you're legally responsible to meet. It's a very important part of this
And you can
process.
still use you could utilize cloud compute with it. So that's kind of the main point, right?
Absolutely. Yeah. And what we'll find is that you can shift data workloads. Data is something that you can move to a different organization. You can move it back into the cloud for an operation. You can bring it back on premises. Inside of a cloud service provider in country, you can use it against their compute infrastructure. Again, simply that you're governing that data sovereignly inside of the laws, if you will, of your own country.
Right. I think that's a very valid point, that a lot of sectors of the economy in Europe that we see are worried about, and they're implementing new strategies like critical infrastructure, medical services. I think banking, not so much. I think banking is hyperscaler all the way in, that we see in many countries. There's definitely a rethinking around there as well, and evolving architecture thinking is. How should I put it? There's a need to discuss this, because strategies that have been adopted at many large companies need to be revisited, right? Need to be rethought. Like you said earlier, that when everyone thought we're going to the cloud 2-3 years ago, and now it's like, okay, we can still do that, but maybe a hybrid component is something we never thought about that we should think about now.
Yep, absolutely. And I've had board members of different organizations sort of confront us directly. In past lives, it was about being in a hyperscaler. And they would ask questions that, you work for an American company, several of them are, of course. And they said, how do I know that the data I store with you isn't in the hands of, say, the American government? And I'm like, I'm not a government official. I'm simply representing a hyperscaler. But I can tell you that as you put that data out into systems that are beyond your control, beyond your location, you have that lack of control. And of course, being on premises, you don't have that. Being sovereign within a country, you're able to put your hands directly on it or work with your CSP to do that. So it's an important discussion that everybody's got to have. And it's something that I feel comfortable saying with a system that you manage. You want all of the capabilities of a hyperscaler. So let's say you want to develop an application. That application needs to use a software development kit. Which one are you going to choose? Are you going to make one up? A lot of organizations we work with will use hyperscaler software development kits because they're common. They're almost a standard out there, which is fantastic. What you want, however, is that software development kit to work the exact same way against other systems. Let's say, again, a Cloudian hyperstore. We recommend using hyperscaler software development kits because we are 100% compatible with them. The idea there is your application is going to work in the cloud exactly the same way it's going to work on premises. So you don't have to worry about, let's say, the test development that you might do in the cloud when you bring that on premises and scale for production, that you're going to have any concerns. That is a very big issue with programmable storage, as I call it, like an object store. And that's an important step to being able to be comfortable in a hybrid environment. Maybe build, test in the cloud, run in production on premises. And I kind of go back and forth between on premises and a CSP, but in this setting, they operate almost the exact same way. They're sovereign. there's something you can point to. You work directly with your vendor to provide that.
Right. And this also, I think it goes beyond the legal requirements, right? I mean, even though when the legal requirements clearly allow you to fully utilize the hyperscaler, there still might be risk assessment reasons that you take within your own company, especially if it's a government organization or a critical infrastructure organization, where you say, well, we're aware of that, and we're okay with slightly higher cost and a slight inconvenience,
Yeah.
if you will, but to manage this thing separately, but we're going to get the best of both, right? Of being in the cloud and of having control and over sovereignty over the data.
Absolutely. I sometimes will use the slightly archaic or outdated English terms, but if you are responsible for the storage or the data systems that are supporting your business and supporting your AI, you are a steward of that data. A steward is responsible for the care of that throughout its entire life cycle. Very general term, but also kind of, I think, very elevated in your concern to make sure that data is safe. In the past, we might have said it's protected, it's in multiple locations, but today, it's much more about, is it sovereign? Do I know exactly who's had access to that? Can I trace the access to that through direct access audits of that data system? That's a very important step in the process. And as we move into an AI world, let's say you've built or let's say augmented a model for training with your own personal data sets, your own business data sets, of course. You want to be able to say, has that data changed? How do I know I have responsible AI, and what data did you use to train that? This is a constant challenge for large language model, foundation model producers. But as you make a customized model that's specific to your business, you are responsible. You need to be a steward for the same thing. So you need to point to that data that is being used to train models. How do you know exactly that the data hasn't changed? How do you know who's had access to that? That's a very important step in the process. Object storage, in particular, a Cloudian platform, but you can govern that data because that's sort of the next step is to say, I have stored it, I've locked it, meaning I know it hasn't changed, and I know exactly who's ever had access to it at any point in time. So now I'm taking that stewardship a little bit further with some of the governance that I have to lay down on top of that data. So in my mind, that says, I need to do that whether I'm in a cloud, whether I'm on premises, whether I'm operating with a CSP. It's certainly a very important step in the process that you need to be thinking about. Again, stewardship, a bit of a big word here, but important.
Right. No. I think that data stewardship was I never thought about it. It's actually an archaic word, but it does get used. Data owners, data stewards. And we see that the more you build these knowledge bases, vector, knowledge graphs, all the more clear, good, well-governed proprietary data you bring in, the more this system architecture view comes into play, and the more critical it becomes that you get good at that. What do you think is there a cultural gap, or what is the gap between the people that are actually building the models or like adapting the AI systems and the kind of the system architects and the system infrastructure people, and how to close that gap?
Well, I think part of it is, let's say if you started building a foundation model, and I happen to have worked with several of these companies before I came over to Cloudian, they were hungry for data sets. They were literally buying, there's a data exchange out there you can buy data on. Ideally, it's been sanitized and there's no privacy issues with that data. I think that's somewhat debatable. But the idea is,
Ideally, yeah.
yeah, ideally. And I feel like that's, how would you demonstrate that? We can talk about that. But the point is they're going to grab a tremendous amount of data. They're going to take any kind of data, and that data isn't going to come from one type. It's not going to just be text. It's going to be multimodal. We want to bring together any one of those data sets. But the key is a lot of organizations don't think about the multiple phases of, let's say, rolling out an AI application or an AI model for business purposes. The first step, as I mentioned, is capturing the raw data, storing it, and locking it so that you have it and you guarantee it's never changed. Okay, great. Is that in step one? Is that something your organization is doing? If I were auditor in chief of such things, I would say that stewardship requirement is the very first step. But the second step is you change that data for the purposes of training and augmenting a model. So you might have to go through a data prep, a data processing. Super common that you pull out the key elements of, I don't know, text or audio signals that you want to understand for training. That's big. It's been part of any kind of business analytics, it's always finding the data inside that's most important. Often your data set is reduced from something that's quite large down to something that's smaller because it's the essence of what you're looking for. Then, so now you've created another version, you lock that data to guarantee that hasn't changed. But then that data is what's fed into your model. Now, your model is likely, today's world, you're likely to use one of the large language models because there's many out there. They're hard to build. They're expensive to build, but you can use them. You can lease them and put them in your business. But if you want, let's say, to create a model that's customized for your business, then you take the raw data that we talked about, you take the process data, and you augment, you continuously train an LLM with that data set. So now I'm in the third phase of training. Now, training usually is where you start to require a lot of high performance compute, and you start to be able to need to train and even what we'll call checkpoint that data back into storage so that if you have a disruption in training, you can keep up and continue to operate. So now I'm in the third phase. I have another set of data that I have to save. So, the gap that I see is that our organizations, number one, looking across all four phases, I'll come to the fourth in a moment, and are they governing that data at each step? Now, a single system, again, like a Cloudian hyperstore, can provide a bucket, a common term in cloud storage, to be able to meet those needs. That's how we've built that system. And it's super important that people be able to take advantage of it. The last step, that phase 4 that I mentioned, is really the inference or the operation of your AI application against data. Now, that is where the model is based on all the data we talked about, is likely to be augmented based on what you're going to ask it for. Is it a chatbot? Do you need to take in the most recent chat information from, let's say, a call center? That's a very important step. And you might need to store that data and augment the training. But look, in these big 4 phases of an AI workflow, are you, and again, back to your question about the gap, are you governing and storing that data at each phase? Can you demonstrate that back to your organization? Now, some of these data sets are going to be public. You're going to grab those data sets and maybe you'll connect with them. That, again, is also very common. But one must be very careful to take in the data that's most useful and guaranteed, or at least say taking the responsibility to serve that data and answer those AI related issues as your customer goes out and operates with their AI solution.
Yeah, it's, two caveats that I want to comment on. One is also in the context of, let's say, critical infrastructure enterprises that maybe don't even have that, like they're not training their own models. Okay, they could have a RAG or something, but they're not. But they're still, due to the nature of their business, are higher risk in terms of AI usage and have a high level of requirements in terms of data sovereignty, etc. You'd still want to go with a hybrid infrastructure, right? There's, in this case, it's not about all those intricate details of being able to do on-premise object storage that looks like the cloud, but more like utilize all the risk management aspects of the hybrid infrastructure. That's one part of the question. The second part of the question is, who is the user other than AI? Because AI cases, yes, we're seeing more and more obviously, this is where everything is going, but it's not all AI, right? I want to go is it's not just to try to do AI, but there's like good BI and normal analytics cases that would make such an architecture relevant. Do you think that's the case? Or is this a use case for people that are organizations that are really training very complex models?
Well, I would say it's both. And it's part of why the hybrid model is so important for organizations. So let me start with, a hybrid model, and this could be a hybrid between your on-prem, a hyperscaler, a CSP, any of these are very important because you're unlikely to be an expert in the tooling necessary or the tooling that you can take advantage of as a much larger organization would be. So for example, we talked about the phases, the storage phase, the first phase, kind of simple, basic. The second phase of data prep, there are incredibly good tooling systems with data warehouses, with ETL tools, where your data set might need to be prepared within a hybrid model. You may need to shift the data set up to a hybrid model for the right preparation to extract the right value. And that's a case where you want to be able to move that between your different operating models, like I said, hybrid, CSP, or on-premises. In my mind, that's where the real value is going to come in. And that's why there's never a chance to say it's only going to be one story, one platform, because another organization is going to find access that you couldn't have. I think GPU availability is one of the most basics. Organizations might be saying, do I buy GPUs and put them on premises? That's certainly one option, but scarcity has driven organizations to shift data sets to the cloud for just one element of the processing because they have GPU availability, even a certain cloud region. Now, what I found in my time with hyperscalers, I mean, we know that these are physical things behind our compute and our storage, is that the GPU availability might be in a region within a hyperscaler that is outside of your sovereign control. This is where you might shift data to a region that is back in the United States or even in South America or wherever because they had GPU availability. That is super common, but it also leads to this maybe sovereign concern of why you want to be very careful about managing those data sets and that control. And then I think organizations today will find that large language models, for whatever workload they're going to use, those that are produced foundation models, are pretty good. You might not get the right results from the first model. Many organizations I'm working with will essentially license multiple models for you to choose as a customer. So you can take a large language model that's licensed through your on-premises operations, through your CSP, through your cloud, your hyperscaler, and test whether you're getting the right results out of it. Organizations that say, I want to build my own model, they're taking on a huge task with tremendous amount of expense. And is it really going to be needed or worth it? Which is why when you take tuning of a model with, let's say, the specific documentation of, I don't know, a manufacturer, an airplane manufacturer maybe, that's a very important part of the data. Then you also want to use that when you operate in a RAG solution. Massive scale training may be limited to different organizations because it's so large and so expensive. But everybody will want to tune models and they'll want to operate an inference with a variety of different models. So
Exactly.
You're never going to have all of the tools you want to operate in your own data center. You're going to want to reach out to cloud providers and different service providers to access and integrate their tooling. They're just simply going to be the experts in the area. I think we've seen this most interestingly with the AI results that went from first produce a chat bot that will answer questions and give me results. Then it was give me an augmented generated image that I'll describe it and fantastically fast they produce it. So now we're seeing AI video, we're seeing all kinds of things where a huge amount of the work we're doing is augmented with AI. That's where I really believe every organization has to have a story. Every organization needs to see the tools, all going to be driven by their data that they need to, of course, maintain control of.
I'm a great fan of that type of thinking because it's like you own and control your data, and then the cloud is like just someone else's GPUs, right? For you care for when you need them. Because for many, having GPUs at all is questionable whether you need that, right? Because the way you inference or your tuning requirements might not be as high or as frequent, or it's just like the classic case for cloud compute that we had in the earliest days of the cloud. It's true also for GPUs. So, but yeah, let's talk a little bit about cost now that we're on that. Where do you see organizations bleeding money in terms of, or in ways they don't realize when thinking about this data and kind of not only AI but also data and AI infrastructure?
Yeah, I think part of it is some of the things we just talked about, like the cost of infrastructure upfront. It's a difficult pill to swallow when you buy all your infrastructure under capital expense upfront because, as always, how much do you need? So what you really want to buy is the needed infrastructure that can scale. So organizations maybe are overbuying up front. I would even say there's probably some overbuying in GPUs because it's like a land grab. People want to get access to them now and put them on premises. But right now, as we speak here, how many GPUs are essentially idle where that cost, the money that was spent on those is not bringing enough business value. So I think people need to be very careful of buying into an AI-ready infrastructure that can scale so that they're going to buy what they need today and know and understand exactly how I'm going to scale that. By the way, that's again why hybrid is such a great story. The cloud proper can do this very easily. You often pay just for what you use. I think organizations don't understand about most hyperscalers that not every storage service is just pay as you go, like price per gigabyte. Many of them are priced per allocation. So the same kind of concept sticks in there where you say, well, if I need a petabyte of storage, I've seen this more with block storage and file storage than with object storage, but you might end up paying ahead of time and not actually being able to realize the value of that storage. So just because we're in a cloud, don't think it's all going to be pay as you go. You still have to tightly manage that. So there's an area where organizations are overspending. I think people misunderstand the way to use storage cost effectively. For example, the cloud's going to offer you a bunch of different tiers of storage or classes of storage at wildly different price points. And that is incredibly efficient, right? If your data isn't necessarily being accessed regularly, it might benefit from being on a lower cost tier. Now, the issue you have with that is the minute you put it down there, there's usually a higher cost to write or put that data to the lower cost tier. So you're incurring a cost beyond just the price per gigabyte. It's usually called an ancillary cost, maybe API charges, but you also are going to incur retrieval charges. So if you make a mistake, and I've seen a lot of organizations make mistakes that says that data is actually needed, now you're moving it back, you're paying almost this rather large charge to bring it back and access it. So clouds can give you a lot of great capabilities of that different price point. But when you're operating, you need to be sensitive to those ancillary charges. So people make mistakes. An on-premises system, I think you control that much better. It certainly can be built with different classes of storage, much like any cloud. But you need to understand, do I have to incur charges to move it around? If it's your system, you're sort of charging yourself. I mean, that may be something you decide to do, but normally it's not as significant. And so if you understand the use of your data, how often it's going to be accessed, even things like the object sizes, because every object sort of gets its own attention. That's part of what object storage does. Those costs can be quite extraordinary if you don't carefully manage them. So similarly to making sure you understand your needs for compute, you have to understand those needs for storage. If you work with any team like mine, architectures, they're going to be asking you constantly, average object size, how many count, how often are they going to be accessed? That is to understand the architecture and the potential costs. So that's an area you have to be really conscious of.
Yeah, it's actually a great insight into all the complexities behind that, because it really is not obvious. What you think is fixed is variable, and what you think is variable is oftentimes in large chunks fixed, right? So
yeah. How often have your listeners been surprised, a cloud cost bill that surprised them? I can tell you in my time with hyperscaler, I was often having to speak to customers about why they had these charges. And it's all very clearly documented on many, many, many pages of documentation. It's hard to keep it straight. That's all I'm saying.
I mean, it's a very interesting thing, because it seems to me also, listening to what, let's say, Snowflake and Databricks are saying. I mean, it seems like no one is after making money on storage, right? Their story there is more like optimizing the compute, right? But it's also valid that, especially if you go into multimodal and you really use a lot of it, and as you mentioned, the way you access it, etc., you will incur, without even thinking much about it, also significant storage costs, so that you might be overpaying for.
Storage is, as a two-phased approach, I say. Storage is something that you must do to protect your data, to have access to it. There's a lot of reasons why. And there is cost associated with it. I mean, let's understand clearly, there's infrastructure behind it, hard disks or flash drives. It doesn't matter. There's something there. But everybody should be storing data, ultimately to use that data for some business value. That usage cost is often what drives the larger organizations. So Databricks and Snowflake are automating the usage of your data. They're providing a very strong and valuable service on top of the data that you have stored with them. And that's really your pay for value, right? So that makes perfect sense to me. Everybody's modeling on how to do this is going to be a little different. And you and your organization need to understand that. Number one, to take full advantage of it. But number two, not to overpay either.
Exactly. The question is, can the infra people really think in terms of business value, or is it too siloed? Because it's a highly technical discussion that often, I think, is misunderstood on a management level, even though the cost behind it might, if you sum up, add them up over the year, not insignificant.
Absolutely. I always say the infrastructure people need to be in the room for these conversations, in part because they may not necessarily know everything about a data set or how it came to them or what it's going to be used for. But as they hear that conversation, What they can do is say, let's say data has been ingested and is being stored. Again, call center recordings, that's a great example. They're storing it, they can point to it, they know what it is. They're all in a safe bucket to be stored. But they also might say, hey, I can extract that data or copy that data or move it into another system that would provide very fast access to, let's say, some data processing or some data training or for inference. Their knowledge of how the infrastructure works gives the organization a much better opportunity to take advantage of the data at the right cost. Because if you're not aware of the infrastructure's capabilities, you may decide, oh, hey, let's move that all back out to the cloud or move it out to another provider, incurring a tremendous cost when the infrastructure person in the back of the room is raising their hand to say, hey, we can do that internally because of the capabilities of our storage platform or our cloud service provider. So they have to be in the room adding value every step of the way. The disconnect, that silo, I see regularly as a challenge, and it leads to that problem getting more expensive and more difficult. I say, bring your people together, get them in the room. Let's see what ideas they have.
Brilliant. I think it's a great way to look at it. Before we close down, so if you were to make a prediction, what a smart enterprise data architecture look like in what's like 5 years from now? Maybe that's too much, but let's say 3 to 5 years from now. What stays, what goes, and what gets centralized, what gets decentralized? What would be your bold prediction on where this is going?
Well, I think some of the things we've talked about here will become commonplace. I mean, go back 10, 20 years. There's always been data protection, and it was constant. Well, I should say, there was an organizational shift that said we simply must protect data as a matter of course. That's in place right now. Every organization subscribes to that or generally should subscribe to that. Going forward, it's that every set of data is potentially useful. It is worth saving and preserving and making it part of this useful AI infrastructure. I think that's going to become commonplace. And if you follow that notion to a conclusion, then you must be using the tools of your hyperscaler, of your on-premises storage, of your CSP to enable that from the beginning. The one thing everybody needs, they already understand, but I think we lose track of, is that store with the intent to use, meaning put it in a place, put it in a location so that you can take advantage of it. I'll pick on a technology that's a little outdated, but one of the things I've often said about tape technology is it's a great storage medium. It's been around for literally decades, and at a price point almost nothing can touch. The challenge is it's very hard to use tape data. Finding it, getting it back online, it is not readily accessible. Asynchronous might be a term you use. Where in truth, what you need to be able to do is access that data easily and securely. So when you talk about moving forward, you're going to make that just a foundation of how you operate. But I think a more important bit is data is big and important and heavy and hard to move. We're going to see a continued push to bring compute closer to data. You may be aware and have followed, NVIDIA obviously is a driving force in a lot of the AI markets. But at the last GTC conference in March, Jensen Huang was on stage and he introduced the AI data platform. And this was a very generic sort of technology talk that was oriented to a lot of storage providers who are looking to use the capabilities of GPUs directly in storage processing. Why do you do that? Well, you do that because where does your data reside? It resides in a storage system. If I can do some of the data processing in or very near in to that storage system, I'm going to accelerate and make greater efficiency out of my storage platform. So what you're going to see is storage platforms will become, they already are, data processing platforms. This is super important. You'll see GPU embedded in storage, and you will see perhaps things like some of the processing I talked about, maybe something as simple as a translation engine being run directly on a storage platform. That efficiency and that scale is going to bring tremendous value. And so your movement will be from being an efficient, cost-effective storage provider to being a data processing provider. And I think the NVIDIA technology, probably along with other GPU companies, are going to be right there helping us make that happen. But to me, that's the shift that 3 to 5 years from now is going to be embedded in storage. You can call it smart storage. I'm not certain I like that answer just yet because we're not sure how smart or how much. But there are so many things to be done in storage with the data. And as we open this conversation, the storage drives the data that drives AI. So it's common sense, I think, that we get there very quickly.
Very, very cool. And I concur with that. And I think they're moving to more into the software stack of it, closer to storage that we're going to be seeing a lot more than that. And there's going to be real use cases combined with storage that we just don't see right now. And but it's also probably too early for that, where the AI adoption has to reach a much higher grade than it is right now in the enterprise workflow, way beyond ChatGPT and the like, and more into
Sure.
actual processes where you have like you mentioned earlier, sensor data, all sorts of stuff, the actual real company data being touched by that technology. Awesome stuff.
Exactly.
I think it was a great discussion and conversation with you. Really
Thank you.
enjoyed your insights. How can people find you if they want to talk to you?
Sure. Again, Peter Sjoberg. I'm the Vice President of Worldwide Solution Architecture with Cloudian. Check me out on LinkedIn and check me out at Cloudian.com.
Great. Thanks so much, Peter. And cheers from Vienna, Austria.
Thank you very much.
Bye. Bye, everyone.